Know by now that the glycolysis takes place in the cytoplasms and leads to the formation of two molecules of pyruvate, paired molecules of glucose. These pyruvate molecules are converted into acetylcoenzyme, also known as acetyl-CoA, and this happens inside the mitochondrial matrix. Therefore, acetyl-CoA is the key metabolic intermediate glycolysis in the citric acid cycle. For clarity, we will not show the coenzyme portions of acetyl-CoA, and instead are simply representing it as the 2-carbon molecule acetate. So how does pyruvate get into the mitochondrial matrix? This depends on the carrier protein that transports pyruvate into the mitochondrial matrix, whether it is oxidized to form acetyl-CoA by the enzyme pyruvate dehydrogenase. Reactions, a molecule of carbon dioxide is generated as pyruvate is oxidized to acetyl-CoA, and a molecule of NAD+ is reduced to NADH. This last reaction is not shown for clarity. The citric acid cycle consists of the following 8 steps, and also harvests chemical energy producing a total of 3 NADH molecules. In the first steps of the citric acid cycle, the enzyme citrate synthase combines the 2-carbon acetyl group from acetyl-CoA with the 4-carbon molecules oxaloacetate. This generates the 6-carbon molecule citrate. In the second step, citrate is isomerized into isocitrate by iconitase. In the third step, isocitrate is oxidized by isocitrate dehydrogenase, generating the 5-carbon molecule alpha-ketoglutarate. In the process, 1 carbon dioxide molecule is released and 1 NAD+ molecule is reduced to NADH. In the fourth step, alpha-ketoglutarate is decarboxylated and oxidized to produce another molecule of carbon dioxide by alpha-ketoglutarate dehydrogenase. The resulting molecule is combined with coenzyme A, forming succinyl-CoA. In addition, another molecule of NAD+ is reduced to form NADH. Note that in this diagram, we are showing the product of these reactions as succinate and are omitting the coenzyme A for clarity. In the fifth step, succinyl coenzyme A is converted into succinate by succinyl-CoA synthesis, releasing coenzyme A. These reactions also produce 1 molecule of GTP, another high-energy molecule which is omitted from this diagram for clarity. In the sixth step, succinate is oxidized to formulate the succinate dehydrogenase. Unlike all the other enzymes in the citric acid cycle, succinate dehydrogenase is embedded in the inner mitochondrial membrane and is also a component of the electron transport chain, in which it is also called complex 2. As complex 2 oxidized succinate is received 2 electrons, that it will ultimately pass on the coenzyme Q, which in turn will deliver its electrons to complex 3. Another interesting aspect of complex 2 is that it uses FAD rather than NAD+ to accept electrons. In the seventh step, fumarate is converted to malate by the enzyme fumarase. And finally, in the eighth step, the enzyme malate dehydrogenase oxidized malate to reform oxaloacetate and reduce a molecule of NAD+ to NADH in the process. This generated oxaloacetate can then combine with another acetyl-CoA.